Assalamualaikum and a very good day. I bid to all hello audience. So first and foremost, I'd like to welcome all of you to the Advances in Geophysics webinar series, in which this special webinar is organized by Geological Society of Malaysia in collaboration with Center of Seismic Imaging UTB. And so now today's webinar series is actually our fifth webinar series, and it will be related to the challenges and way forward on the geophysical monitoring for subsurface and near surface. Right, so before I pass the floor to our speaker today, allow me to share with you briefly about the background of our today's speaker. So today's speaker is Dr. Hardian Shah Saleh, who is currently a lecturer in Geology Program, Faculty of Natural Resources, University Malaysia Sabah, UMS. He is also currently attached to UMS Natural Disaster Research Center as Research Fellow, while advising UMS GSM Geology Club since its inception recently. Now, Dr. Haider Shah received his BSc in Geology from UMS, MSc in Geology from UKM, and PhD in Geomechanics from University of Leeds, United Kingdom. As an academic, Dr. Haider Shah has published in numerous publications and presented in local and international conferences, colloquium, and seminar. His research focused in near-surface geophysics, exploration geophysics, as well as seismic geomechanics, which he used his knowledge and expertise towards characterizing the subsurface and near-surface conditions, such as landslide and slope monitoring. Right, so Dr. Haider Shah is currently a professional technologist with the Malaysia Board of Technologists, as well as professional geologist with Board of Geologists. Now, without further ado, I'd like to invite Dr. Haider Shah to deliver his talk on geophysical monitoring of subsurface and near surface, the challenges and the way forward. Please welcome, Doctor.
Okay. Assalamualaikum warahmatullahi wabarakatuh. And good afternoon, everyone. So, all right. So, thank you for the introduction. Thank you to the organizer for having me today. All right. So, to be honest, I'm not really expert on this subject, by the way, but I will try to share to the audience what I did during as a researcher and as a lecturer as well, and during my postgraduate time during that time lah. Okay, so I will try to have this more on cozy or santai lah, kata orang kata, session yang lebih santai. Hopefully everyone able to share their thoughts during the end of this my session. All right, so moderator, so I have 1 hour, right? And we have 30 minutes Q&A. Is it right?
Yes, Doctor.
All right. So, okay. So, thank you very much on that. So, basically, based on my observation on the audience today, so I'm not really sure about your background, but I believe that today, our webinar today, the people that attend to this session have a totally different background. So I've seen here there are students, and there's a lot of people from industry as well. So I do believe that everyone here have their own expertise, have their own thoughts, and maybe have their own point of view. So I didn't want to make everyone agree with me. This is just about my sharing and my experience, and I'm looking forward if any one of the attendee for this webinar able to share their maybe a little bit experience during Q&A, our Q&A session. All right. So, okay. So today I'm going to talk about geophysical monitoring for subsurface and near surface. So the challenge and the way forward. So this is what I've been through for a few years back, especially when I'm starting with my master's degree in UKM, University Kebangsaan Malaysia, which is kind of starting point. Okay, during my degree, basically, my background is more on geology, but I'm starting to get into geophysics stuff during my UKM. So University Kebangsaan Malaysia gave a lot of input in me. So I think a lot of my friends as well from UKM. I think they are come attend today. All right. So basically, I will share about the what is geophysical monitoring and what the current situation and maybe what we're going to do for the next maybe 5 or 10 years. And most of the situation or case study in this my sharing station is most likely is based on the Sabah situation. Okay, so it didn't represent the total condition or the general condition. So it's more on the localized or small region representation. All right. So I do believe everyone know that what is geophysics about. So it's a kind of combination between two big field of study, which is from geology and physics. So it's combination of big and major, by the way, which is we could say that this is totally two different world. So geologically, you need to observe it on the field. While physics, you able to prove it in the lab. So so combination with these two, then we call so as a geophysics field. So in geophysics as well, so there's a lot of application that we able to explore. So within geophysics, there's a lot of branch as well. So there are geophysics in deep earth and they are with subsurface. So I will go on that. So basically, this is what the model of our Earth. So there are 1,000 meters about the diameter. So basically, we have crust, mantle, outer, and inner core. And I believe that this is the stuff that we learned during our primary school or secondary school. So during science, so everyone know that this is the layer of our Earth. But in geophysics, we divide that into two. So the first part is we call so as near surface and subsurface. So this is consists of most likely dominantly of our crustal, our Earth crust. Okay, while the rest is deep earth. So I'm not going to discuss about that because that is not my stuff, or I'm not have any experience on that. So deep earth is there's geophysicists as well study about deep earth. So that is even which is I do believe have their own challenge for that. So today I'm going if well, I will try to share about the what the situation on geophysics and near surface. So basically within condition in Malaysia and some case study from the we call so from the European continent. All right, so this is the crust. Okay, so this is the cross section of the crust. If we have cross section, we're able to cross the crustal. So basically, our crust, our Earth crust, is around 30 to 40 kilometers. So it depends on the location. So if we have a continental crust, normally it's even thicker, especially when located within the boundaries about continental crust and oceanic crust. So the crumple zone, we call it as a crumple zone. So tempat pelanggaran two plates. Okay, so 30 to 40 kilometers. So basically, maybe we if we see the numbers 30 to 40 kilometers, it's kind of not so big deal. Okay, but could we imagine that Gunung Kinabalu, if you have seen that, in Sabah. So Gunung Kinabalu is around 4,000 meters above the sea level, the peak. So basically it's around 4 kilometers. So it need to be stacked around 10 Gunung Kinabalu to achieve that, the thickest part of our cluster. So it's a massive massive layer, which is it quite challenge to understand for every layer. All right. So for the near surface or subsurface, most likely we are looking for the 5 to 6 kilometers on here. So it's around even though in oil and gas exploration, normally we're focusing on this layer. So if you could see this model, so it divided into two. Okay, so the first a few hundreds or tens meter from the above, we call it as a near surface, while the rest is the subsurface. So they are slightly different in terms of depth. So basically it's the same rock formation, but there are definition on near surface due to the as a human being, we are really direct contact with this nearmost outermost layer. Okay, so some of the definition. So this is some of the definition. What is the differences between near surface and the subsurface itself? So we go to the near surface. So man interacts with this part of the Earth crust. So most likely we live in here, in order to achieve development, or we want to build a building, means any infrastructure that we need, that normally we will communicate. We call it as a communicate, or we will explore this layer. So near surface is really related to us. It's really near to us, while the subsurface somehow it could be up to a few kilometers. So if we look at to the oil and gas, for example, oil and gas exploration, the subsurface or the reservoir layer could be up to a few kilometers, which is far into the deep layer of the crustal. So it's we call it so quite far away from us. But we still do exploration on that. So this is typically the difference. But in terms of geological scale, so basically near surface and subsurface is basically the same. Okay, the same. But in order to explore that, there are the classification is there, because normally the near surface we interact a lot compared to the subsurface, which is up to 4 kilometers or 5 kilometers from the surface. So normally we didn't really interact with that, just only for the oil and gas industry or the carbon capture and storage industry. So I'm going to discuss one by one for this part. So the definition of geophysical monitoring. So basically, what is geophysical monitoring? So geophysical monitoring is basically we do geophysics on the same location, or we observe that for repeated measurement in order to detect long-term change. So this is applicable to the near surface as well to the subsurface. So monitoring data, basically from the data that we have, which by using the standard geophysical model, so example, gravity method, or magnetic method, or resistivity, or seismic. So basically, if we do that to observe the subsurface, and in order to measure the change, or in order to identify is there any change within the subsurface or near surface, then we call that as a geophysical monitoring. So in terms of geology, I'm back to geological term. This monitoring could be done by different method. So geophysics is one of the method, and there are also engineering perspective in order to identify the changes of the geological characterization or geological properties. So engineering do as well by using their own method, and there is also from the geohazards analysis and GIS analysis as well by using the satellite image and so on. So there's also doing that. But on geophysical monitoring, we focusing on the standard method that established in geophysics method itself. All right. So I'm going to share about the case study of the geophysical monitoring. So I'm the first one, the first section I will go not discuss but more on sharing about this geophysical monitoring for the subsurface. So we go to the bigger scale first because most of the geophysical monitoring method, which is for if you go to seismic or if you go to the electrical method. So most of this method is developed in for the subsurface, or we call it as the big company such as in oil and gas. So most likely this technology developed by there and then adapted to the near surface application. So so for instance, we most of this monitoring is involved heavily in oil and gas and carbon capture and storage, or we call it as a CCS. So oil and gas exploration, I believe that even though you are not apa nama dia exploration geophysicist, all we know that most likely we need to deal with a very thick layer of rock formation in order to find out is there any oil or gas or hydrocarbon that we could manipulate or we could extract. So that is in the oil and gas. And while the CCS is more on we find the rock formation that able to store our carbon into the beneath of the layer. Instead of release that carbon into the atmosphere, we store that excess carbon into our ground. So that is the win-win situation. Normally, these two industry, oil and gas and CCS, normally they have heavily collaborate. Normally because once we extract the hydrocarbon, normally we will left out a huge amount of space. So in order to use that empty space, then we could manipulate that area to be we able to put kind of excess carbon from our industry. So this also kind of win-win situation. So we didn't release that carbon dioxide into the space, so we could reduce the greenhouse effect, and we have we call so as try to reduce the climate change as well. So so that is another perspective. But for monitoring, so it's heavily being used in oil and gas as well, but not for exploration. So exploration is another thing, but instead of just thinking about making money in oil and gas, so most of the company realized that as a human being or as the professional company, we need to be professional for our job. So especially in oil and gas industry, once we able to extract the oil, it's not the end of the job. We need to monitor what going to happen to the subsurface itself, because we believe that our subsurface is dynamic. We call so as a dynamic condition. So once we disturb the system, basically it will change a lot of things. So once we extract the oil or hydrocarbon underneath of the subsurface, basically we change the pressure, we change somehow the condition. Even though it's a very small portion of it, maybe we couldn't see that by our naked eye, but for the long term period of time, that gave significant changes. So especially in this condition in oil and gas exploration or extraction procedure. So when we extract the oil or gas for quite long time, uh, so it tend to change quite big condition characterization of the subsurface. So that's why there's been idea to monitorize this procedure. So not just think about the we able to extract the hydrocarbon and that's it. No, basically the professional company or the big company need to monitor this condition during the process and after the extraction complete. So they need to at least to monitor on this, because we didn't want to have a condition and catastrophic condition in the future. So at least we know that the real condition or the exact condition at the moment. So we able to plan what next. So for example, in oil and gas industry, I give that example as well. For exploration, normally they have some time of period of time to extract the block or the reservoir. So they need to deal with the owner. Kalau dekat Malaysia maybe Petronas lah kan. So so the owner of the area to, if they want to extend even more. So once their contract has been ended, so they need to even maybe to plug ataupun to close out the reservoir. So we need to understand once at the end of this process ataupun at the end of the extraction procedure, what is the condition within the subsurface, because that there are potential another exploration will be being done afterwards. So the reservoir able to be maybe open to the another company or another contract will be open to who company want to bid or even maybe do kind of enhancement oil recovery. Let's for example. So they will looking forward for that. At least they know the condition has been slightly changed before and after the extraction procedure. All right. So this is an example. Normally, this is an example in the oil and gas monitoring. So normally, some say we call it as a time lapse. Some say they call it as a 4D or 4-dimension seismic monitoring. So if we look at here, normally this is the standard stages in oil and gas exploration and production. So there are pre-production, production stage, and post-production. So pre-production, normally we do kind of for this situation, we do seismic data acquisition in order to understand what the condition of the subsurface. Is there any change, and evaluate the subsurface. Is there any chance to have a good reservoir, or how big, how much the petroleum we able or hydrocarbon we're able to extract from this area. So once the evaluation, the assessment or the decision has been made, if this area is really kind of able to give profit, so the production will begin. So before the production, they will have exploration well, assessment again, and then need to match with the data, another data, geophysics. So during the production, they here on this stage, then we start to have like change the real condition. Okay, so during the drilling itself, during the exploration itself, we already slightly changed the subsurface condition, and then during production, even drastic the change. Okay, because we extract. Let's say this is hydrocarbon. The black area is hydrocarbon. Then we extract that. Basically, we change the stress and the pressure underneath. Okay, not just about the rock itself. It's also changed the pressure. So not only human being have a stress, the subsurface as well have their own stress. So because it's down deep below the surface, so the pressure is even higher compared us that living on the surface. So so that's why this is even more complex. So once we have a production stage, so we change the pressure and effective stress underneath the subsurface. So for the monitoring purposes, instead of doing the geophysical survey during the pre-production, normally for monitoring purposes, we will repeat that method exactly at the same coordinate, the same location. So we will do repeat, and then we will try to see is there any changes in terms of if we go to seismic analysis, then we will see a lot of the seismic attributes of the velocity. Is there any change of the velocity and the amplitude itself, and VOA, and a lot of seismic attribute. So so that things not just ended there. So basically, we could use that the data that we collect during the pre-production and the post-production, we could do kind of historic matching in order to produce a prediction simulation. So this is really important to the next future, because we able to give kind of we able to sneak peek into the future, such as like that lah. Okay, so we able to produce a prediction model. So what we able to predict, if let's say the extraction is still going for the next maybe 2 or 3 years, then we able to predict how the subsurface being changed. So that is really important in order to reduce the risk. So recent, I think the last 5 years, there's a few big cases in the Elgin Franklin, I think in 2016. So they are kicking pressure. So when they are underestimate the pressure changes underneath, so there are gas leakage on that situation. And I think if you have watched the Horizons movie, so that is based on the true story, the condition that the catastrophic an incident in Deep Horizon exploration area. So that is happen when we underestimate the pressure change during the when we want to close down the drilling hole. So that is another thing that we need to consider about it. And based on the monitoring as well, we're able to plan what our next we call so as a next planning. So if the pressure change in here, then what we should do. So that is may reduce the risk of such a incident in deep horizon. So we didn't want to have that. So that is the simulation. So this is a standard diagram if you deal with geomechanical or hydrogeomechanical monitoring. So hydrogeomechanical means we monitor is there any changes within the rock properties and the liquid itself, or any material that lies or that trapped inside of the rock properties. So this is an example of, I think this is the easiest or the simplest diagram that hopefully everyone could understand on this. So if we have a pre-production like this here, so this is standard geological or we call so as a hydrocarbon trap. So we have cap rock, reservoir, and the burden, or somehow there are source rock from here. So if we extract petroleum or hydrocarbon from this reservoir, basically the overburden or the cap rock itself could be the stress will be kind of, we call it as elongated or decreased. So on this portion, while the side or the side burden increase. So it's not we call so as a homogeneous changes. So there's a lot of different changes. So this is what some other researchers have do kind of research. So this is another proof that our Earth, our subsurface, in terms of stress changes, is not homogeneous for the whole layer. So there are some layer, maybe at the same depth, but different structure could have increase instead of decrease of stress. So that is the thing that we need to monitor on that. Okay, so this is another model that during my PhD. So this is a Snowy reservoir, or we call so as a Snow White. Snowy is from the Norwegian language, while in British they call it as a Snow White block ataupun Snow White region. Okay, so this is the model that I have, and there are velocity model and so on and so on. But the thing is, this is what we monitor on the during the injection and depletion. So so injection will involve if we have recovery mode, or we call it as an enhancement oil recovery. So this is very obvious change. Means once we inject material inside of our reservoir, for example, in order to force or push the left hydrocarbon that unable to extract it by using standard method. So we kind of force them by enhancement oil recovery. So somehow we use kind of hydro fracturing. So we force, so we make a secondary kind of damage lah. Okay, in the subsurface. So we force it out from its trap area. So basically we change even more the condition of the subsurface. So that is the thing that we need to consider during the monitoring as well. So this is another example. Then this is more on modeling. So we able to model the Snowy just now, and then we could based on the pressure change, then we could repeat. This is another thing we call it as modeling. So once we have the historic matching just now like this, so we're able to manipulate this stuff. So we're able to predict if we extract this much for, let's say, 1,000 barrel for 5 years. So what happened if we use sorry?
EMS
So is there any question? Sorry. Chairperson, is there any question? I'm not get it because I can't see my chat box. I'm not sure.
No, Doctor.
Okay. Oh, mungkin turn on mic. Okay. All right. Okay. So that is the thing that we need to think of. So based on the historic matching, then we're able to predict a lot of simulation based on our trajectory. So if we want to extract a bit faster, then what going to happen? Or if we want to extract even more per day, maybe we want to increase 5,000 barrel per day, tambah lagi, and so on. So we're able to predict what going to happen to the subsurface. So basically, this stuff has been through the oil and gas industry for almost 2 decades, more than 20 years. This monitoring situation has been through, and a lot of improvement has been done. And I'm not going to say that the simulation always perfectly able to predict what going to happen, because this, we call it as a prediction. So but recently, within the last 5 or 10 years, the prediction even more robust, or even more able to represent the real situation in the subsurface. So that is the thing that I will discuss a bit later on this my webinar. All right. So that is for the subsurface. So just a simple experience, short term of experience with the subsurface monitoring. So what happened for the near surface? So like I said, like I mentioned just now, near surface is even more near to us. So it's we have interact directly with this depth of layer. So if we want to build a building, or if we want to any infra that we want to develop, then we have to consider this depth of layer, or this rock formation within this 10 up to a few hundred, or some say just around 100 meter from the surface. So most likely that the situation that I've shown you just now about the monitoring within the subsurface being used nowadays into the near surface. So there is a lot of condition, or situation, totally different situation that this kind of method have starting to being used. Okay, but there's still a lot of challenges, but because of the condition with the subsurface and the near surface is slightly different in order to acquire the rock sample, or the subsurface information. So I will try to share. This is the definition that I show you just now about the what the near surface is really about. So like I said just now, it's totally we live with that, directly contact with that. Even though you're not a geologist or not a geophysicist, maybe different background field of study, normally we will have to deal with that. Some say if you have like a flood, so everything is really close with the near surface, and what the material that within that area. So that's why it's really really close to us as a human being. All right. So this is the application normally for the near surface. Normally we're able to monitor on this. So we have slope stability, which is if you are from ICRAM or JKR, so this is the thing that have been done a lot of time. Mining as well, archaeology, groundwater, geohazard, and construction. So so the geophysical method has been used for this sector or for this division. So a lot of achievement have been done, but I'm not the one able to use all of this application towards all this field of study, just a few of it. So I will try to share the a few of my uh, experience, some of my experience. So this is another experience from groundwater monitoring. So this is in Sabah, we have a lot of small island, and then in terms of clean water supply, there's a lot of challenge in Sabah, for instance, because our condition is not, say, we have a big area. The Sabah set is huge, but in terms of population, we are quite small. So the people living, it's kind of scattered. So it's not as highly populated like Semenanjung, Malaysia, but we have slightly kind of scattered. So the infra is quite challenging. So the basic infrastructure. So this is the condition in Balambangan, Balambangan Island in northern part of Sabah. So kalau if you look at the map of Sabah, so the northern part we have a Bangi Island, and this Balambangan is just next to the Bangi Island. So Bangi, I think the biggest island after Labuan, maybe. Okay, so please correct me if I'm wrong, but that is yang setahu saya lah. So one of the biggest island. So in Balambangan, there's a lot of water supply problem. So we try to monitor a few of the condition. So this is the situation when there's a dark well ataupun perigi, okay, telaga cetek lah, okay, dekat tempat in within the area of the penduduk ataupun orang kampung sana lah. So there is a dark well, so they're able to get the water. But the problem is when they try to drill at within the near with the school, they want to make a hostel for the school because the people that live there is some of them is from quite far away from the school. So instead of traveling a few kilometer every day, so the local government tried to build a hostel so they didn't need to walk every day, so they can stay at this hostel. But when we did survey that, the dark well really they have water, but on the school, within the school area, after they produce a quite deep well, tube well here, okay, the contractor couldn't find any water on that time. So they call us in University of Malaysia Sabah to help them find out why there's no water within this area, while just a few meters away there's a dark well, a lot of water. So what we did then, we do kind of do geophysical survey at the same area a few times. So we monitor that. We find out that there's totally different rock formation within this kampung and the school area. So that's why the water from here can't breakthrough or flow within this subsurface. So so they have to find out another condition lah. Okay, and this is another challenge, and then I will talk later on about this challenge, about the location itself. So I think that is during my end of presentation, I will share a little bit more, okay, about that. So this is another situation, dam monitoring. So this is one of the result that we did from dam in Sabah. Okay, so this is the cross section of this is the drawing of the dam, one of the dam in Sabah, because there are concern about that, about the rigidity or stability of the dam, because this dam is quite, I think it's almost 20 years of construction there. So they want to make sure if the dam is still able to stand with this condition, or is there any enhancement, or is there any job to be done in order to stabilize, or in order to make sure this them always serve the purpose. So this is the condition. Then we run a lot of survey line within here, and a few times, and there's still most of the dam is quite steady, but there's a small hole, or we call it as a small portion of it have need to be kind of monitor even more detail. So geophysics data able to give it like a quite big area. So but if we looking for to the small cracks or small leakage or small instability, so we need to use another tools. So this is another example on that for dam monitoring. So this is another example as well. So we cross-check with the borehole that being constructed during the early stage of this dam. So it's really good correlation on that. So this is another example for dam monitoring. So besides dam monitoring, we also use this method, resistivity for saltwater intrusion monitoring. So if you could see, this is a time lapse in Labuan, Pulau Labuan, okay, wilayah Persekutuan Labuan. So we did one line, survey line, and we monitor, we repeat that data acquisition for several times. I couldn't remember how many times we did that for a few days. So we able to detect the changes of the saltwater intrusion during the low tide and high tide. So it's really related with the tides condition. And recently we did in another area in Sabah, in Papar, for example, in here, we did monitor that for different monsoon or different season. So the rainy season, how the how this saltwater intrusion react, and what happened during the dry season. So that is another example that we could use this monitoring, and the slope monitoring as well. This is one of location in Sandakan. So we monitor a few of the slopes. So there's a failure of the slope within this area. So one of the company call us and try to find out what causes or what really happened within this area, because they have like big problem to deal with this. So we try to help, and we apply with the geophysical method in order to reveal what really happened within that area. So this is basically, this is Sandakan formation for those didn't know about the Sabah geology. So this is Sandakan formation, and basically there are potential of toppling within this area as we observe within that condition. So what I'm going to say on this, it's more on that our geophysical method able to monitor that the movement or the subsurface condition, which is if we able to apply that or monitor or put our instrument quite a few times or different situation, maybe for a few time of period, maybe 1 or 2 years, then we able to even uh, more understand on this stuff. Okay, and this is landslide monitoring. So as well in Kundasang, so we did that as well, and this is basically we have grant on this with Allahyarham Dr. Tajul. Okay, so he's the one who insists to start this project. So he want to monitor the all dormant landslide, or we call it as tanah runtuh pendam tua. So we believe that the landslide that happened uh, within Kundasang, Sabah, there's a huge system as well, not just small portion, but instead of developed by huge region or area. So this is landslide monitoring. And recently, we have a recent situation in Batang Kali landslide. I think we pray for them, for the victims, and basically this is what the situation that we use GPR to identify. But this is not more on monitoring, but this is more on exploration kind of, because uh, the thing has happened before we do kind of observation. So if we want to apply a monitoring, we need to monitor before the landslide happen, then we're able to compare it once it's when the event or once the condition has been done. Okay, so this is I think this is GPR from the GeoVentures, my friend as well from UKM, done claim. Okay, Zul. Okay, so this is his company helping out to find out the victim. So the geophysical method is very we call so as a very uh, what's the right word? I couldn't recall that. Versatile. Okay, so yeah. So geophysical method is very versatile in order to solve a lot of problem, especially when we deal the structure or anything that below the surface, or we call so as the subsurface. So that is the thing that we're really looking forward on that. So yeah, so that is the recent situation. Hopefully these things it's not going to happen, but it's really hard to say that we able to stop this condition. But what we able to do as a geophysicist or geologist, we able to reduce the risk. If we find out there are risk area, then we able to reduce the maybe amount of victims. Then that is our aim, to solve or uh, to totally stop that event being happen. It's almost impossible, because that is uh, how the earth works. It's always there are dynamic system in our earth. So the thing is always happen. Then the human or the human being like us, we only able to try to understand what really happened on our earth. Then we able to adapt on that in order to reduce the risk. Okay, so that is more on the geohazards perspective. Then what is the challenge and the way forward for this? So the challenge, this is one of some of the challenge. I'm not going to share about all the challenge, because I believe that every condition, every exploration, or every geophysical survey have their own challenges. So this is what from my experience is the challenge is more on the data acquisition and data processing and interpretation. So I divide into two main group. And basically the near surface have to deal with this, while the subsurface normally have to deal with this. All right, so we go to the
Dr. Hardesha, Doctor, you're currently in mute.
sorry, saya termute kah? Okay, boleh dengar?
Yes, boleh.
Oh, okay. So, saya tidak tekan apa-apa. Okay. All right. So sorry for that. So the challenges we divide into two. So data acquisition and data processing. So data acquisition, it's on more long-term monitoring. So because we need to repeat this, the measurement. So during my experience for the saltwater intrusion, we have seen this kind of problem, okay, because we want to put our electrode at the fixed area, but in order to get the permission or uh, the ownership within that area, it's really hard, because somehow you need to deal with the private sector or the individual land. So that is another problem we face out, that I think it's really hard to solve that at one situation, because like I show you just now, the condition when we do this exploration about monitoring the groundwater, uh, these people they ask for rental if we want to extract water from his duct well. They ask for rental, monthly rental, in order to supply the water to the school, which is for his own child. So I somehow it's kind of out of world to think about that, and that is for your good. But yeah, so different people have their own different perspectives, so they thought that this should be paid to them, even though that is the usage is for their own child. So there is another thing that I think science unable to solve that thing, because it's more on human being punya problem. Okay. So another challenge is on the external factor, ownership and availability. So, and during this, I mentioned about the living lab. So living lab is kind of, normally geology have the lab is on the field. So you have to deal with the people, you have to deal with the surroundings, the activity, human activity as well. So somehow it's a lot of challenge to deal with that. External factor, research area, ownership, like I said just now, availability. So somehow we want to that exactly that area, but it's not available for us to access. So that is another problem that we normally have been through. But it's not really happen for the subsurface, because subsurface normally the monitoring normally on the offshore. So when the offshore, you need to deal with the government or the ownership of the land, let's say Petronas or whatsoever, the management. So yeah, you have to deal with one party instead of near surface. You have to deal a lot of people and so on. But for subsurface, nowadays we got a challenge on the data processing and interpretation. To collect the data, it's quite easy. Not easy, but it's kind of being standard at the moment. So a lot of device or the instrument become even more faster and robust and easier to get acquire the data. So the problem with this situation, in order to monitor that, we have too much data. So how are we able to produce an unbiased data interpretation? Because we are, as a human, we have every human. There's no natural person in this world. So every have their own perspective or their own preferences. So this is the thing that we need to consider on that. How we deal with this for the challenge of the data acquisition, it's really hard to deal with that because every condition or every monitoring is really unique. So there's no absolute answer on that. And nowadays, near surface even go through this stuff because near surface nowadays become we able to acquire a lot of data. Not like the last 20 years, near surface to get the data is quite take time. But nowadays we have a lot of data from a lot of company have their own machine or instrument, so we able to gather the data. And I believe that for the next maybe 5 or 10 years, then we will have this condition like just the subsurface. Means we have to deal with the large data. Then how are we able to process on that? Because the data is too much in order for us as human being to consider and to analyze that. So to put that problem forward, so another forward the way forward on this problem. Uh, for the problem with the human being, it's really hard to solve that. So somehow we need to deal with the law enforcement and so on and so on. So it's a lot of things to do. But in order to deal with the big data, so this is if you go to the any conference that related with geophysics, it always be AI or artificial intelligence or machine learning. So there is the way forward of any if monitoring geophysical monitoring as well. If you deal with near surface or subsurface, especially for subsurface lah. So that is the thing that we always or we need to think about it. So my idea is uh, the programming should be as a science language. So in the developed country, okay, I do believe that our country is starting to going that direction as well. So programming not just mathematical method, but it's more on the science language. So every science background should at least learn on this stuff, programming. Let's say MATLAB, Python, programming language at least. I just learned that during my PhD, so it's we call it as a bit too late, but it's still beneficial and which is give us a lot of flexibility because with if you're able to understand the programming or the coding language, we don't really need to rely on software, or we call it as uh, a commercial software, which is somehow the software is quite expensive and so on and so on. So that is the thing that maybe we need to consider on that. So in the university level, I do believe most of the universities start to embed this programming stuff within their program. So in University Malaysia Sabah as well, in program of geology, we try to uh, embed this. At least they have trained or know that the program is very powerful in order to help us in the next couple of years, because when we deal with a lot of data, then we need that. And artificial intelligence, just like I mentioned just now, machine learning, deep learning, and I think one of our speakers uh, for this webinar as well has been discussed about the AI. So there is always, not just for the subsurface, not for just for the uh, we call so not just for the uh, subsurface exploration or hydrocarbon exploration, but I believe that this stuff will be involved in the near surface as well. So when we want to deal with the landslide, when we want to deal with the groundwater system, when we want to deal with the saltwater intrusion instance, so we need this machine learning in order to help us to give even more unbiased interpretation. Like I said just now, human is always biased. So geophysicists always have their own preferences. If they want to say that this is very highly potential of landslide, so if so many data provided, they have like intuition to match with that. Excuse me. So that the thing that I think that we need to consider that. I do believe that most of industry or the the company are also looking forward for this, not just to help us, but to to make our interpretation even better. So sorry for that. Tiba-tiba batuk pula ni. Alright, so I think that is the idea for that. And I think that's it from my presentation. Exactly 1 hour. Lebih sikit. Okay, so chairperson siapa tadi eh? So maybe we will go to the Q&A.
Right. Okay, so thank you, Doctor, for the very insightful sharing just now about the challenges and the way forward in the geophysical monitoring. And so from the audience, if you have any question that you'd like to ask Dr. Hardian Shah, you may do so by turning on your mic or just typing the question in the chat box.
Hai, Assalamualaikum.
Okay.
Assalamualaikum.
Sorry.
I'm Jamaluddin Rosman. I'm just going to refer to your near surface monitoring program or project that you have done. Okay, I'm not talking nothing related to subsurface because that is not my field. In the beginning, I was really looking forward to your talk because I thought it was totally on near surface geophysics, but I was mistaken because then I look at the title back. There was a term or word there which mentioned subsurface. Then I realized that you are talking both on the subsurface and also on the near surface. As for your definition, near surface is basically, to me, near surface is basically less than 200 meters long, all right? And it's not related to ONG industry. That is my own personal definition. Okay, let us look at your monitoring project that you have done. Something related to groundwater, saline water intrusion, right? I believe that I think 99% of your presentation on the projects are based on ERT, electrical resistivity tomography. And I believe that this is the equipment that UMS Sabah own, right? So you don't have a lot of choice. You don't have a lot of selection as far as equipment is concerned, method is concerned. And I think you are also familiar that there are other geophysical methods, things like potential field methods, electromagnetic methods, and all the other things. All right. Going back to your saline water intrusion studies, I would look at it as something that I believe that there will be issues if you are using ERT because you are dealing with saline water intrusion. You know that saline water intrusion, if the current hit the saline water, which is very conductive, the current tends to be stuck there and won't be penetrate deeper. I would have thought that using things like electromagnetic method, especially the transient electromagnetic method, is much better than using ERT, right? But I don't blame you because since you're only having ERT system, so you do that. But personally, I believe that channel transmission using ERT is going to be a problem there. Okay, so that is one thing. And I think that the way forward, right? You mentioned about the way forward, AI, machine learning, and those kind of things. And your issues with the owners getting data and those kind of things. I think on top of all that, I need to mention that I believe that universities, all the local universities, should be at least 70 or 80% equipped with good geophysical system equipment for all the methods. That is very important, right? I've been trained years ago. I've been exposed to a lot of methods, seismic, magnetic, gravity, and those kind of things. So this is something that I feel that if you're doing your research and development and looking for the way forward, you cannot just focus on ERT or GPR, right? So there are things which are much better applied, geophysical methods which are much better applied than ERT. This is the task of the geophysicist to decide which of the methods which are very suitable for the particular project that you're going to carry out. Okay, so that is my comment. So on ERT and also on the way forward. Thank you, Doc. All right.
All right. Thank you very much on that for very insightful ideas. And yeah, thank you, Mr. Jamaluddin Othman, which is, I know this guy is, kalau in geophysics, he's big names in geophysics. So I'm nothing to compare with Mr. Jamaluddin. But okay, for the limitation, yes, we know that the university has been limited with the instrument. So basically in University Malaysia Sabah, we already have a seismic, but we didn't fully utilize just yet because of the apa nama dia, we have another project on that. It's still ongoing, so I didn't share the results in within this my presentation. Basically, for the landslide condition, we also deal with using seismic refraction, but the data still not finished to being processed. So that is the thing. And for the saltwater intrusion, yes, we aware that if we use the ERT or ERI system, so there's a limitation on that. So how we able to counter on that instead of just basically depend on the geophysics, we also use the standard geological or hydrogeological analysis. So we collecting samples from the borehole, and we produce a few dark well in order to acquire the and cross-check with the geophysical data that we have. So it's not solely or totally depend on the geophysical result. So I do believe all the geophysicists always cross-check with the rock formation on the field. So that is what we have done. And for the intrusion, yes, electrical resistivity always have a problem with that, especially when we deal with the high saline water. And for TEM, yes, thank you very much on that, transient electromagnetic. Recently, I just discussed with EBM. We try to find funding instead of because of this is more quite promising instrument. I do believe on that. So we're looking for that if we able to acquire this instrument TEM, and hopefully we have that budget lah to buy this. This is the next instrument that I'm looking forward. Basically, In UMS, we have magnetic instrumentation, which is exactly the same with USM, GEMSIS, and we got problem with the battery system. So we still didn't sort that out, the problem. So basically, we have three. We have seismic, resistivity, and magnetometer. So the TEM and gravitymeter we don't have because these two instruments quite expensive. So that's why we have very limited option on this example. So hopefully we're able to collaborate with the industry. So and the problem with that thing as well, that if in Semenanjung, Malaysia, then we have option to collaborate, a lot of option, but in Sabah we have a limitation in collaborate with the industry and maybe do kind of joint venture research. So because there's not much company that really have their own instrument, complete instrument, I mean, in geophysics. So thank you very much on that. And yeah, I think thank you very much, Mr. Jamaluddin, for that. I'm really appreciate that that insightful ideas. Thank you.
You're most welcome. Just a little bit of, can I a little bit on your discussion? So the thing is, I'm glad to hear that you are UMS going into, at least looking into the purchasing of TM. That is a very good, right? That is a very good machine, a very good equipment, right? The only thing is that my advice is do not focus into one model or brand. So compare them, right? I know that a lot of the industry, a lot of the universities, I'm not promoting any company, I'm not promoting, but I think there must be option, right? So you have to look into the various options that are available to you. There are many in the market, doctor, right? So don't focus on one brand. Look at the strength, look at the price, and make a good decision to buy a good TM system. Thank you very much.
Okay, thank you very much for that. Yeah, we also consider a few brands as well, so just not one. So yeah, thank you very much, Mr. Jamaluddin.
Okay, Assalamualaikum. Do we still have time?
Yeah, I think
Okay.
basically I have a meeting at the moment.
Okay.
Oh, yeah, still have.
Still
Okay.
maybe last one. Okay, Assalamualaikum, Dr. Adrian. First of all, I would like to say that it was a very good presentation saying about monitoring and so on. And my intention ataupun one of your presentation has caught me caught my attentions, which is about the monitoring of the subsurface, particularly on the CCS project. We know about Sleipner field for CCS injections, and Snowfish. Snowfish is also well known for CCS project. Probably because your study is related to Snowfish, I believe your study also related to the CCS. And probably you can share with us the geophysical survey that has been conducted in Snowfish field for MMV monitoring in general, besides seismic and hydrogeomechanical analysis as per se. For example, non-seismic monitoring, if there is any, or if there is none, perhaps you can suggest one or two geophysical methods besides seismics that probably a good potential for CCS monitoring.
All right. Okay. So thank you, Mr. Nur Amin. So basically, Amin is my close friend. So tanya kawan. All right. So untuk another data, basically we have very limited. Not we have the data, but in terms of to publish or to use that data easily, it's quite challenge because it's owned by several companies, not just one. So we have to deal with a lot of things. So other than seismic survey, basically we do doing a lot of lab tests. So most likely more on the rock physics stuff. So and we compare with the other reservoir within the North Sea reservoir or the subsurface. So based on that, instead of just relying on the seismic monitoring, we also try to mimic or try to replicate the subsurface condition in the lab. So we put the pressure and then we try to see how the velocity have been changed with this type of rocks and how about another type of rocks that exist in the subsurface layer. So that is the thing that apa nama dia yang biasanya kami buat lah. But to share with you the other data, I'm really sorry on that because I'm not on the data, which is I need to deal with my supervisor during my PhD dulu. So he's the one who able to allow or to share the knowledge. The thing that I show you that is still able to share, but not the real or the apa nama dia, the raw data. So only the output. Okay, Amin.
Okay. Seismic is okay kan? Perhaps maybe your point of view on monitoring using gravity or FTG full
I don't have
method.
That could be, yes. I believe that they have that data, but I'm not jump into that because another who did that, not me. So that is a big program project, by the way, PET gas project. So yeah, so that's it.
Okay, thank you, Dr.
Okay, sorry, saya ada meeting lain. Sorry, I'm really sorry. Saya punya nama kena panggil sudah ni. So, sorry pada pengerusi. If we have still time, so maybe I'm looking forward if we able to have a quick chat. Okay. So I have to go now. Sorry for that. Chairperson, okay, boleh?
Alright, boleh.
Okay, so thank you very much for the attendance. Thank you very much. So just contact me if we have a good chat. Thank you very much.